So let's run through a couple of these homework problems. Um, let's see, I don't have the number written down here that we're supposed to factor. Hold on about that. We are supposed to factor, in this example, the number 45. So I like to make prime trees. And this one will be fairly easy. What I do is I first think of two numbers that multiply together and give me 45. And when I think of that, all I can think of is 5 and 9. But of course, there are others. You might have thought of 3 and 15. But regardless, you want to keep going until you get to all prime numbers. This is not prime, but 9 can be written as 3 times 3. And I like to keep bringing down the prime numbers until I have this row of all primes. Now, in WebAssign, they don't give you very clear instructions how to enter this answer. You're going to use that little star key to write this as 3 times 3 times 5. So this is a problem with WebAssign, if you ask me, because I had to figure that out. I couldn't figure out how to put in my answer. Okay, before we move on, I want to talk a little bit about prime factorization and finding greatest common factors. Suppose you're dealing with a problem and the coefficients are 54 and 36, and you need to find the greatest common factor of these two numbers. Well, the first thing you want to do is get the prime factorizations. So make a prime tree. So let's start with 54. I know that this is 6 times 9, and we can keep going because 6 is not prime. 6 is 2 times 3, and 9 is 3 times 3. So what do I have? I have 54 equals 2 times 3 cubed. Now let's do 36. When I think of 36, I think of 6 times 6. That's not prime, so I keep going. 2 and 3, 2 and 3. And it doesn't matter where you start. You might have started with 3 times 12, but you get down to everything being prime. So this equals 2 squared times 3 squared. Now, to find the GCF, that's our second step. We kind of build this. We're going to use only the common primes. So what prime numbers do they have in common? Well, shoot, they both have a 2 and they both have a 3. Okay, so how many 2s and how many 3s? Well, we're going to use it the fewest, well, let's say the smallest number of times that they appear anywhere in a prime factorization. The smallest number of times they appear. So here's my GCF. How many 2s do I want? Well, I have 2 2s here. I have 1 2 here. I have 2 2 here. So I need to use 1 2. 2 to the first power, if you like. So use 1 2. And how many 3s do I want? Over here, there are 3 factors. Over here, there are 2. So I want 2, the smallest number of times they appear. This is 2 times 9. This is 18. That is the greatest common factor of these two numbers. And if you just looked at these two numbers, 54 and 36, you probably would say 9. 9 is what you want to factor out, but actually you want to factor out 18. Now, if you started by factoring out 9, you would soon realize that you can also factor out a 2. You do not have to use this method, but sometimes this can come in handy for finding a greatest common factor when the numbers are a little bit bigger than you want them to be. Okay, back to the homework. Like number 3 in 3.4 homework, which is also known as homework 14. One of the questions says, is this factored completely? Well, look in here. Are there any common factors in here? Yes, there is an N. So no is the answer here. Now you might get one that is, so don't just put down no for your answer. But that's how you check. Check to see if they factored out all the common factors. What should we have factored out? We should have factored out 3m cubed n squared, and that would leave 2n plus 3m squared. Okay, now we're asked to factor this completely. 39 is what? This is 3 times 13, and 12 is 2 times 6, which is 2 times 2 times 3. So the greatest number, the greatest common factor of this is 3. How many x's can I factor out? I can factor out 3 of them, right? How many y's? 3. Now, remember how we determine what's left inside. Let's just make this all green since we did that. Divide this by your greatest common factor here. I would have a 4. The x cubes cancel out, and I'd have a y. Do the same thing here. Divide this by your greatest common factor. I would have 13x, and that's it. And you can check by multiplying it back out. Do you get what you started with? Okie dokie. Let's first see if these numbers have a common factor. 17 is prime, isn't it? 23 is prime. So the greatest common factor of these numbers is 1. So we're not factoring out a coefficient. We're only going to be factoring out a power of x. What power of x can we factor out? The smallest one, x squared. And then just see what's left. Divide each of these terms by x squared. I get a 9 minus 17x to the 4th plus 23x to the 5th. And then check. So remember how I'm doing this. To get that last term, for example, I just took 23x to the 7th and divided by x squared. And that gave me my answer. Factor by grouping. My first instinct is to try to just group them as they are written, and I see that that doesn't work. So rearrange. What shall we do? Let's get the 8's together 8AC plus 8BC. And then let's get the 7s together. Plus 7BD plus 7AD. And now I can group these, and it's all addition, so I don't have to worry about minus signs, which is nice. And then I look to see what I can factor out. I can factor out an 8 from these first two. I can also factor out a C. What does that leave inside? A on this one and B from this one. Okay, what about over here? I have a 7 and I have a D. So factor out 7D. What's left here? B. What's left here? A. And of course, that's the same thing as A plus B. And now I have a common factor. So that's the goal. If you don't end up with a common factor, you might have written down something wrong, or maybe you made a little mistake along the way. So factor out A plus B and see what's left. Here, it's 8C. Here, it's 7D. And there is my final answer. All right. Now, these last two, we're just going to solve an equation. Remember, we want variables, in other words, our polynomial on one side of the equal sign and 0 on the other. So let's get the 6a on the left-hand side by subtracting it from both sides. And now we can factor. What do we have to factor out? An a. That leaves me with a minus 6. Now here we set both factors equal to 0. So either a equals 0 or a minus 6 equals 0. So we have two solutions. Here we have to do a little more work because this is a linear equation. Hopefully you can see what you would do. You add 6 to both sides, right? So my answers are a equals 0 or a equals 6. And in WebAssign, I think you'll just do something like this, or they might ask for the smaller number and the larger number. But this is a comma separated list. If you see that term, that's what they ask for sometimes. Not too bad. Here's another one. This one's already set up, so just factor out that x. You might say, what's left when I divide x by x? 1. What's left when I divide 8x squared by x? Well, that's going to be minus 8x equals 0. So either x equals 0 or 1 minus 8x equals 0. Now here we have to do a little more work. How do I solve that? I'm going to subtract 1 from both sides, get rid of that 1. I'll have minus 8x equals negative 1. And then remember what we want. We don't want a negative 8x as our coefficient. We want that to be a 1. So divide by -8 to see that x equals 1/8. So my two answers are x equals 0 or x equals 1/8. There are two solutions. Last one. All right, I need to get 0 on one side, so what would I do? I would add a squared to both sides. Then that will become 0 on the right-hand side. 19a plus a squared equals 0. You might want to rearrange this. A squared plus 19a equals 0 because that's our proper form, but it doesn't really matter. The thing we're going to factor out is a. So a, if you divide this by a, you get a. If you divide this by a, you get 19. So either a equals 0 or a plus 19 equals 0. So I have a equals 0 or a equals -19, right? I have to subtract 19 from both sides to get that. And again, you're probably going to be entering 0, -19 on WebAssign. Okay, let me know if you need some more examples or if you need any help.